Hello, good morning, dear students. Welcome to my next session on dimensions and dimensional analysis. Okay, actually, these dimensions of physical quantities are the powers of which the fundamental units have to be raised to obtain its units. The expression representing physical quantity in terms of powers of fundamental units are known as dimensional formula of the physical quantity. So, what is the dimensional quantity of physical quantity? It is expression representing physical quantity in terms of powers of fundamental units, means mass, length, time and their powers. Also required here the dimensional formula of the physical quantity. So formula, from the formula, if you write the expression, then that is called as dimensions of physical quantity. Equation obtained by equating the symbols of physical quantity with its dimensional formula called dimensional equations. So now we will see what are the points I have discussed is the dimensions of physical quantity are the nothing but powers. The dimensions of the physical quantity. Dimensions of the physical quantity are the powers of to which the fundamental units have to be raised to obtain its units. Another important thing here to remember is the expression representing a physical quantity in terms of the powers, of the fundamental units, powers of the fundamental units is known as expression. This expression is known as the dimensional formula of the formula of that physical quantity. So first we have to remember what is the dimension. The dimensions of the physical quantities are the powers of the fundamental units have to be raised to obtain its units. The second one is nothing but the expression representing a physical quantity in terms of the powers of the fundamental units is known as dimensional formula. That is called as dimensional formula. Once we know the formula, we can easily tell what is the dimensional equation. Now we will tell about the dimensional equation. That is nothing but the equation obtained by Equating the symbol of the physical quantity by equating the symbol of the physical quantity, symbol of the physical quantity with its dimensional formula, with its dimensional formula, with its dimensional formula is called the dimensional equation. Dimensional equation, which is called as dimensional equation. See, what is the dimensional equation, what is the dimensional formula, and what are the dimensions of the physical quantity or the powers of the fundamental units, and all discussed in the 3 points. First point we have discussed about the dimensions of physical quantities are powers of which the fundamental units have to be raised to obtain its units. The second point is telling about the dimensional formula, that is the expression representing physical quantity in terms of the powers of the fundamental units, known as dimensional formula. Third point we told about the dimensional equation, that is nothing but the equation obtained by equating the symbols of physical quantity with its dimensional formula is called as dimensional equation. Okay. Next we will go to the principle of homogeneity. See a question here. Find the relation for the force of on a small sphere dropped in a viscous fluid, given that it depends on its radius, speed, viscosity in the fluid. So we have taken force is equals to K into R power A, viscosity power B, and velocity power C, where K is taken as constant of proportionality. And each and every quantity we have written the physical units. R is length, L power 1. Viscosity is m, L power minus 1, T power minus 1. And velocity, L power 1, T power minus 1. Force is m power 1, L power 1, T power minus 2. So in this formula, if you take m powers, so m powers is only 1 is there, that radius R power A we have taken, and viscosity we have m is there, viscosity power B means m power B came, and force which is equal to the principle of the homogeneity concept I have taken, and this L power R power A is there, so L power A, and here L power minus B is there, here L power 1 means C is there, so L power A minus B plus C came. And coming to T powers, so here in viscosity we have T power minus 1 is there, here viscosity power we have taken B means minus B will come, so T power minus B will come, and also here in velocity case we have T power minus 1 is there, that means minus 1 into C is minus C, so T power minus B minus C will come, so that we wrote here, that is m power 1, L power 1, T power minus 2 is equals to m power B, L power A minus B plus C, T power minus B minus C. After equating this one, we have solved, we got B value 1, A value 1, C value 1. So that we have substituted in this one to get the relation for the force on small sphere dropped. That is F is equal to K into R into viscosity into velocity. They are given that it is depend on radius, speed, viscosity of the fluid in the fluid. So that is we have solved. So in the previous discussion problem concept, what we have given is nothing but when you are applying the physical dimensions analysis, you should not have any kind of dimensions constant in the relation. So any dimensional constant is not there in the relation. That's what we saw. For proportionality constant, we have not given any kind of the units. Now, moving on to the next one, that is maximum velocity. The maximum velocity attained by a mass attained by a mass acted upon by a constant force depends on K, M, F. Then find V. So here they are given diagram like this. And is the mass of it. Like this given. This is the force and this is the K value. So this is the problem. Here we have to consider like V is equals to F power A, M power B, K power C. Now we'll write what are the dimensions. V is equals to, that is L power T, L power 1, T power minus 1. And what is force? That is M power 1, L power 1, T power minus 2. What is the mass M? That is M power 1. What is the K? What is K? That is M power 1, T power minus 2. So here, maximum velocity attained by a mass acted upon a constant force depends on K, M, F, find V, they are telling. So in this case, if you apply principle of homogeneity V, what is V? L power 1, T power minus 1, that is equals to, if you take F, in the case of F, what is M power? See here, M power 1, that means M power A. Here we have M power C is there in case of K. So that is nothing but M power A plus C. M power is A plus C, and here also M power B. So A plus B plus C you can write. And coming to the L power here, L is there in V and F is there. So V power F power A is there. So L power A is there. So L power only we have A is there. And T power. So what are T powers here? Here T power minus A is there. Here T power minus 2C is there. So here minus 2A minus 2C. You can write T power minus 2A minus 2C. Now we can equate it. So here this side M power nothing is there. So A plus B plus C is nothing but equals to 0. So A plus B plus C is equals to 0. Another one where L power 1 is there. So A is equals to 1. And we have one more thing, that is minus 2A minus 2C is equals to minus 1. So A value is 1 So we can write minus 2c is equals to minus 2 minus 2c is equals to minus 1. Minus 2c is equals to plus 1. So c is equals to minus 1 by 2. C value is how much? Minus 1 by 2. And we can find now B value. So A value is 1. So 1 plus B. C value is minus 1 by 2. Minus 1 by 2. That is equals to 0. So B plus 1 by 2 is equals to 0. B is equals to minus 1 by 2. So B value also we got minus 1 by 2. That implies what is the maximum velocity attained means V proportional to F by, because F power A is there, A value we got 1 and M power B value we got minus 1 by 2. So F power 1 and M power minus 1 by 2, K power minus 1 by 2. So that means it is nothing but V proportional to F by root mk. V proportional to F by root mk is the maximum velocity obtained by mass acted upon a constant force. Okay, this is the another important constant strand. Concept strand number 4 we have finished. Yeah, let us see some dimensional formula physical quantities. These are, here I am taking quantity formula, this is dimensional formula. Here also quantity, this is the formula, this is dimensional formula. Dimensional formula. So let us see that area is length into breadth. So it is L power 2, M power 0, L power 2, T power 0. Volume, length into breadth into height, that is M power 0, L power 3, T power 0. Density, mass by volume, M power 1, L power minus 3, T power 0. Velocity, displacement by time, that is mass, M power 0, L power 1, T power minus 1. Acceleration, velocity by time, that is M power 0, L power 1, T power minus 2. Force formula, mass into acceleration, F is equal to ma, M power 1, L power 1, T power minus 2. Work, force into displacement, that is M power 1, L power 2, T power minus 2. Momentum, mass into velocity, that is M power 1, L power 1, T power minus 1. Moving on to kinetic energy of into mass into velocity square, that is M power 1, L power 2, T power minus 2. Same like that of work, because work is form of kinetic energy. Pressure, force by area. Force we have, this is area. After combine this, M power 1, L power minus 1, T power minus 2 came. Potential energy, mass into acceleration due to gravity and height, that is M power 1, L power 2, T power minus 2. Impulse, formula, force into time, and dimensional formula is M1, M power 1, L power 1, T power minus 1. Torque is the force into arm of couple, that is dimensional formula M power 1, L power 2, T power minus 2. So that means in this some dimensions of the constants also are there. So that can be obtained from the formula physical quantities. We have gravitational constant is there, Planck's constant, gas constant, Boltzmann's constant, Stephen's constant, Wien's constant, Rydberg constant, Avogadro's constant, Bohr-Macrotons, Hubble constant. These also there, and that list we will see in the next session. Until, have a nice day.